Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll be discussing acids and bases. And to begin with, we will look at the definitions of acids and bases. According to the Arrhenius theory, we see that the definition for an acid is a compound that forms H3O plus ions in water. And H3O plus are called the oxonium or hydronium ions. And if you look at a base has been defined by the Arrhenius definition as a substance that forms OH minus ions in water. And OH minus ions are referred to as hydroxide ions. Then going further, we see that there was two scientists, Bronsted and Lowry, that came up with a definition which seems to be a better definition of acids and bases that we use today. And according to this, the Bronsted-Lowry definition, an acid is a proton donor, meaning that an acid donates H plus ions in a reaction. And when we look at the discussion further, when we look at some types of reactions, we will see how acids donate protons, which are H plus ions. And we see that a base is a proton acceptor. A base is a substance that will accept H plus ions when it reacts. So if you look at common acids that we know, common acids will refer to HCl, which we know as hydrochloric acid. And hydrochloric acid is found in a person's stomach, which assists in digestion. If you look at H2SO4, which is called sulfuric acid, sulfuric acid is found in battery acid, which is used in a car. Nitric acid, HNO3, is a very important component in industry, in the manufacture of fertilizer, where we get fertilizers like ammonium nitrate and potassium nitrate, so that nitrates are very important for plant growth. And CH3COOH is called acetic acid, or we even know it as ethanoic acid, which is the active ingredient in vinegar. If you look at bases, common bases that we know, one of the most popular common bases that we know is NaOH, which is called sodium hydroxide or caustic soda. And we find that NaOH is very important in the manufacture of soap, and it is also found in many different types of cleaners, including drain cleaner. NaHCO3 is sodium hydrogen carbonate, or which we know as sodium bicarbonate, and it is the active ingredient in baking powder, which allows cakes and things to rise during baking. Na2CO3 sodium carbonate is important in the manufacture of glass, and we see that NH3 is ammonia, which is a weak base, which is found as a cleaning agent, and a good example is in Handy Andy. Now, if you look at acids, we looked at HCl, H2SO4, HNO3, CH3COOH. When acids react with water, they undergo ionization. HCl is covalently bonded, and even we look at NH3 is also covalently bonded. Now, when these covalent substances, HCl, for example, reacts with water, we see an ionization reaction taking place where we form H3O plus ions and Cl minus ions. And if you look at NH3, which is a weak base, because it is covalently bonded, when it reacts with water, it forms NH4 plus and OH minus ions. So ionization reactions occur when covalently bonded substances react with water, and we see the reactions as we have here. Now, if we have salts, for example, basic salts like NaOH, which is a basic salt, sodium hydroxide, and it is soluble in water. When you put sodium hydroxide in water, it undergoes dissociation because we see that the NaOH is ionically bonded, and we see that Na plus ions are produced and OH minus ions are produced. So covalently bonded substances undergo ionization reactions like HCl and NH3, whereas ionic bonded substances like sodium hydroxide, potassium hydroxide, etc., undergo dissociation, is the example of sodium hydroxide as we have here. Now, the next point to discuss will be the conjugate acid-base pairs. If you look at HCl, when we react it with ammonia, we see that the reaction that follows is that you get NH4 plus, which is called the ammonium ion, plus the chlorine ion that is formed. Now, as we've discussed in the definition above, we know that the acid is a proton donor. So the HCl must donate H plus ion. And the NH3, which the HCl is reacting with, will accept the H plus ion. So as a result, the HCl will become Cl minus because it donates the H plus ion. And the NH3, which receives the H plus ion, now will not be NH3 anymore. It will become NH4 plus because it received an H plus proton from hydrochloric acid, and it becomes the NH4 plus ammonium ion. We will now demonstrate the reaction between HCl and NH3, showing the H plus ion transferring from the HCl to the NH3. When we have the H and the Cl that are together, and when this HCl reacts with NH3, we see that the H plus ion that is here will be transferred to the NH3. And then we see that because it is transferred, we don't have NH3 anymore. We have NH3 plus another H. We have NH4 plus. So that is what's happening here. The HCl is no more HCl. It becomes Cl minus because the HCl donated this proton that we have here. So the acid is a proton donor, and here we can see HCl donating the proton. And the NH3 receives the proton, which is the H plus, and it is no more NH3. It now becomes NH4 plus. So here we can see that we have conjugate acid-base pairs. So HCl becomes Cl minus. So we can represent this as a conjugate acid-base pair as follows. So we can say that HCl is your acid 1, and the conjugate base will be base 1. So your acid 1 will be HCl, and your base 1 will be NH3, Cl minus. So that we've got our conjugate acid base pair, HCl and Cl minus. Let's see a spelling error here. We can just fix. And if you look at the other example, the NH3 and the NH4 plus, we see that the NH3 accepted the proton, so this will be your base 2, and the conjugate acid for NH3 will be the ammonium ion, acid 2. So here we've got the acid 1 and the base 1. HCl becomes Cl minus, as HCl is your acid and Cl minus is your base, the conjugate base, and NH3 is your base and NH4 will be your acid. And so that will be our base, conjugate base, that can be there. Conjugate acid base. Take this away. Right, so what we see here is that the HCl becomes Cl minus. So HCl is your acid, and when it donates the H plus proton, it becomes Cl minus. So your acid base pair will be HCl and Cl minus. So if we look at this here, we can see that the substance with the extra H is your acid. HCl has an extra H, so it is your acid because it donates the H. And the Cl minus is short of H, so it's your conjugate base. And similarly here, if you look at NH3 and NH4, the substance with an extra H plus is your acid. NH4 plus has more H than NH3, so the NH4 plus will be your acid and your conjugate base will be NH3. Another example. If you look at this example that we have here, where we have HCl and H2O reacting with H3O plus and Cl minus. In this reaction, we can look at our conjugate acid-base pairs, and if you look at HCl, it is similar to Cl on this side, so HCl will be your acid 1, and the Cl minus will be your base 1. And if you look at this other example, we'll see that H2O and H3O plus look similar, and the H3O plus has extra H, so this will be your acid 2, and H2O will be your base 2. So there we've got our acid base conjugate pairs. Similarly, if you look at the next one, NH3 looks similar to NH4 plus, and we see that the NH3 will be your base 1 because it has less H than NH4 plus, and this will be your acid 1. And similarly, if you look at H2O and OH minus, we'll see that the H2O, that will be the H2O will be your acid 2, and your OH minus will be your base 2. So here what is actually happening, what we see here, that the H2O gives the 1H plus, gives one proton to the NH3. So the H2O becomes OH minus and the NH3 becomes NH4 plus. And that is a summary of the introduction to acids and bases.